Hey everybody, this is a little bit more review before we really get into the new pre-calculus material. This is some things you should have really worked on in Algebra 2, but I want to make sure that we remember before we before we just make assumptions, okay? So here we're going to talk about how to solve quadratics, and those are the types of equations that would graph to make parabolas. They make the U shape, so you might have seen it look like a U, or you can see them also look like a rainbow, but that's what quadratics are. And usually when you solve them, you end up with two answers. It is possible to have no answers, like no real numbers. It's also possible to only have one solution, but most of them tend to have two, because what you see when you get those answers is you're seeing where does the parabola hit the x-axis, and they usually will hit the x-axis in two locations. So we're going to talk about how we can solve them and what kinds of methods to use. This first method is called solving by square roots, and that is the type that we get when it's honestly one of the more simple ones. You're noticing there's only one term here that has an x in it at all, versus looking at B, you see there's an x squared term and then an x term. So that is different. You can't solve that one with square roots. But on A, we can, because there's only one term with that x squared in it. There's no other x's, and so we are able to use that other way. So here's the way we're going to solve with square roots. First things first, you're going to get the x squared by itself entirely. So right now this is 3 times x squared. We're going to start by dividing by 3 so that we get the x squared by itself. 27 divided by 3 is going to give you 9. And now we have to get x. Right? What we're seeing is that some number squared equals 9. There are two answers for this, okay? So for me to figure out the answer, the easiest way is to square root both sides, but notice that there are two answers that where if you have a number and you square it, you get the number 9, okay? And those two numbers are +3 and -3. So usually the shorthand way to write that is plus or minus 3. It means +3 or -3, okay? Look at B. B, we have 3 terms. It is already set equal to 0, which is what I would love to have happen when you have these 3 terms like this. If it was not already set equal to 0, I would make it set equal to 0, but we're already there. So it's off to a good start. Now, if you'll notice, the numbers on this are rather gross, and that's okay. I messed around with this one for a little bit first to make sure, but this one is a factorable problem. So if anybody's first instinct when they see a difficult quadratic, if your first instinct is to use the quadratic formula, let me just tell you, this one will be kind of ugly to use the quadratic formula with, because look at how large the numbers are to already begin with. If you use the quadratic formula, really, I would not want to do that unless I had a calculator in my hand, which I guess we could, but you don't always, especially when you take that AP test. Keep that in mind. So if there's a way to do something with without a calculator, we're going to try to do it without a calculator. And this is something we can do. It's just a little challenging. So first things first, my brain looks at this and says, gross. But I notice that all 3 terms do have something in common. The first thing I notice is that they are all even, so they are all divisible by 2 at the very, very least. And so I took it a little bit further and I said, okay, is it divisible by anything larger? And they are actually all divisible by 4 as well. So I'm going to start by factoring out a 4. Now, you guys might have seen your algebra problems where you just divided every single term by a 4 and you no longer kept the 4 in the picture. That is possible to do on a problem such as this, but I want you guys to get comfortable with the idea of keeping 4 in the picture, because in some algebraic problems, it will be important to have that 4 still in the picture, okay? We're going to factor it out. That's going to leave me with 5x squared. And then over here, again, you may not be super comfortable with dividing with 152, but you can just go over to your scratch paper off to the side and divide 4 into 152. I'll review this one pretty quick with you guys, just in case you've forgotten how to divide by hand. But 4 goes into 15 3 times. 3 times 4 is 12. Then we subtract. 15 minus 12 is 3, and we bring down this 2. 4 goes into 32 8 times evenly, so there's nothing left over, and we have 38x for that middle term. All right, you can do something similar with the other one, the 252. So in case, again, I'll run through it just in case some of us are not feeling super confident with our division skills. 4 goes into 25 6 times. 6 times 4 is 24. And then we subtract. 25 minus 4 is 1. Bring down the 2. 4 goes into 12 3 times. So it may take you a minute to do the division, but it really shouldn't be too bad. Some of y'all may be even comfortable doing it in your head. I don't know. Regardless, try to do it without the calculator, okay? And at this point, we're at this moment where we want to try to factor and see what we can do. I'm going to keep the 4 out here. And like I said, I did already play around with this problem. It is factorable, okay? And there's multiple ways that people have learned how to do this, okay? There are, some of y'all may have learned some kind of gimmicky methods where you do this like slip and slide or slide and divide type of method, or there's some people who do this thing with a big fat X. I don't really know how that works. I don't really do those methods. And I haven't really looked into it. But if you already have a method like that that you use, then that's fine. You can use those methods. I'm going to tell you what I'm going to do, which is I usually try just to figure it out. So I try to do like what's called, we kind of call it trial and error or guess and check. And it's literally what it sounds. You do your best, you make an educated guess as to what this could be, and then you check to see if things work. If they work, awesome. If not, then change it and try again. But there are ways to narrow down your answers, and this one is not too bad to do this with. So remember that when you are factoring, we want to break it down to where this first term times this first term would give you back the first number from the trinomial. Because if you had FOILed this, you would start with first times first, right? There is a nice little feature here with the fact that 5 is a prime number, because the only factors of 5 would be 1 and 5. Or you could do -1 and -5, but I don't know why you would do that. So we're going to say 1 and 5. And then x squared can only break down into x times x. So we're going to have a 1x and we're going to have a 5x for that first position in each binomial. That's really the only way to make that work, because 5 was prime. If it was not prime, it might be a little bit more tricky. Now here's where I'm going to grab my pencil, guys, because we are guessing and checking. So I'm going to write in pencil so that I can erase things if something doesn't work out. What I need for my last terms here is I need these last 2 pieces to multiply to be the last piece in my trinomial, meaning I need these last 2 numbers to multiply to be -63. Well, I think of 63, and what immediately comes into my brain is the pair 9 times 7, just because I've got my times tables running in my head, okay? So there are other factors like 1 and 63, right? You also have like 3 times 21, but you can try, and you can try any pair. But the first pair that comes into my brain is 9 and 7, and so let's just see what happens, okay? 9 and 7. It doesn't really matter where we try things. I'm going to say let's try this one being 7 and this one being 9, okay? Also keep in mind, I'll make that a little bit darker for the camera. I usually write these pretty light because that way I can erase it easily. Okay, I also, because they multiply to be a -63, I also need one of these to be a negative number. So I'm just going to pick one to try for and see what happens. The other would have to be positive. So think about what happens if you FOIL this back out. X times 5x does in fact give you 5x squared. Check. We want that. Fantastic. The next thing is outside times outside. That would give me 9x. And then we do inside times inside. Negative 7 times 5x is a negative 35x. So I want you to stop right here. Look at these two middle terms. Do these add to end up being negative 38? No, they don't. They don't even add up to be a positive 38. It's not even close, all right? So right there, I know this is not right. Let's erase what I have and try something else. Now, if the only change was that I got a positive 38 instead of a negative 38, then what I would do is just change the signs to be the opposite. However, I did not get that. It was a completely different number. So I'm going to swap and maybe try the 9 there and the 7 here. Again, I've got to pick one of these to stick the negative with, I think, because this is going to be a negative 38 in the middle. I'm going to stick the negative with the larger number just to see if that fixes it. But I swapped the places of the 7 and the 9. And I put the negative with the 9. So let's see what happens. We know first times first, we're good. We already tried that. The next step to FOIL would be outside times outside. So x times 7 is 7x. Then inside times inside. Negative 9 times 9 times 5x is a negative 45x. And this pair right here, 7x minus 45x, it does add up to be the 38x. So what I'm seeing when I picked this pair is I see that yes, in fact, this works, okay? So that is my final answer. That's my solid answer. I want to make sure it's dark enough for whoever to read it to know that that's what I'm picking. And I've got it factored. And guys, I know this kind of takes a while, but if you get used to it and you're not needing somebody to walk you through it the whole time, this method actually will go by pretty quickly because you're just going to try things real quick. If it works, great. If not, then try something else. And it does go through pretty quickly. All right, I'm going to get rid of my scratch work here because I don't really want it to junk up my space. And the next thing we're going to do is work towards solving. We did the hard part. We did what's called factoring. And now we've got to decide, but what is x? So I want you to think of some common sense logic here for a second. We have three things that are multiplied and equal 0. We have 4 times stuff equals 0. We have this times stuff equals 0. And we have this times stuff equals 0. Well, use some common sense logic here, okay? If you have things that are multiplied to equal 0, one of those factors has to be 0. That's the only way that it works. A number times a number equals 0, one of those numbers had to be 0. So either 4 equals 0, which that's kind of a stupid statement to make. I mean, you know 4 is not 0. That's not it, okay? But also we could have x minus 9 equals 0 or 5x plus 7 equals 0. And we're going to solve these. Again, 4 does not equal 0. We can all see that plain as day. But these other ones we do get possible solutions for. So I'm just solving these through really quick. We get to our answers. X equals 9 and x equals negative 7/5. Right? All right, one more question for you guys. All right. This one looks a whole lot less scary than the last one did. So let's just jump into factoring, see if it works, okay? If you want to pause the video and try it and come back, you can totally do that, okay? I'm going to jump into this. Let's see. If I was going to factor, remember I want the first times the first to be x squared, which means this needs to be x and x. That's the only way to get x squared. Now think about my last terms in the binomial. I need last times last to equal negative 3. So guys, that is either me having a negative 1 and a positive 3 or swapping those signs, okay? So if I try this, remember first times first, x squared, we're good. Outside times outside, that is 3x. Inside times inside is a negative x. This does not make negative 11. so that's not right. But look at this, guys. Even if I swap their signs or swapped the place where they were at, okay, if I change this, outside times outside, that's negative 3x. Inside times inside is a positive x. That is still not adding up to be negative 11x. This cannot factor. It's what we might call prime, okay? So if it can't factor, that leads me to know that my solutions are either going to be irrational or imaginary, okay? So imaginary happens if your parabola does not even cross the x-axis at any point. That just means that the solutions are not real. They are what we call imaginary. And irrational means that it is just that. It's an irrational value. So it could still hit the x-axis. It's just at a really, really gross value, okay? So in order to determine what the solutions are, we have this fallback. And some of y'all may have got to the point where you used it for everything, but I would discourage that because it really is a pain, okay? And it makes you feel like you need a calculator. We're going to do it without a calculator, okay? This is your quadratic formula, okay? So here is the formula. X equals, that we have negative b plus or minus the square root of b squared minus 4ac. And this is all over 2 times a. And when you are deciding what your a, your b, and your c are, that comes from the terms in front, or your coefficients here. So there's an invisible 1 in front of that x squared. That is your a. That's 1. Okay, b is in front of the x term, so b is negative 11. And c is the constant at the end. That's negative 3. Okay, and we're just going to plug all those things into the quadratic formula where they go. So I'm going to say x equals, and we're going to say negative b, but keep in mind b was already negative. So if b is already negative, we're going to go with the opposite of b. It's going to end up being actually a positive 11 for that first number. Then we say plus or minus the square root b squared minus 4ac. So remember, b is negative 11 squared minus 4 times 1 times negative 3. And this is all over 2 times 1. So you see how I said this is gross? If you don't have a calculator, it is the grossest, okay? All right, let's clean this up. We have 11 plus or minus the square root. 11 squared is 121. Then look here, we have a negative 4 times 1 times a negative 3. Notice that there are 2 negatives here, guys. We are multiplying a negative times a negative, which is going to cause this to be a positive or a plus. 4 times 3 is 12. This is all over 2. We're almost done. 11 plus or minus the square root of 133 all over 2. And guys, if this square root, if that radical could simplify, we would simplify it. That's why we practice simplifying the radicals in our last video. But this is not simplifying, so that's the best answer I can give. If your question ever asked you to give decimals, that's when you would need to type that in a calculator. And you would do 11 plus the square root of 133, all divided by 2. And then you would do 11 minus square root of 133 divided by 2. But as it is, this is your answer. Done. All right. Guys, I hope that was a decent enough review on how to solve quadratics. It kind of gave us a really large overview of the different types. I always try to factor, but if it's not factorable, then that's when I fall back on the quadratic formula. All right, y'all. In our next video, you're going to see us actually starting precalculus. So look forward to that, and I will see y'all in the next one.